Hi
So,
then.
today we will go over any questions that you had from the complete ionic net ionic reaction worksheet because you guys have a quiz on that this week. So, and
Just a little bit better and
this
easier to read.
document is in the files. I think I said I would put it up there last week, and then I looked, and then it wasn't there, so I think I thought I put it in, but I didn't. So, okay.
Cool.
So let's take an example here. Okay, so what we're going to do is we're going to do the example of Mg S plus SrOH2. Okay, and our first job is going to be to write the formula equation. So we always start by finding the formula equation. And in order to do that, we write out all the ions with the charges, okay? So what we're going to do is we're going to write out all the ions with the charges. So we have Mg2 plus, we have S2 minus, we have Sr, which is 2 plus, and we have OH, which is -1. Okay, the magnesium and sulfide, you look up those charges on your periodic table, and strontium as well. Hydroxide, you look it up on the table of common ions. So step one, write out the ions with the charges. Write out ions with charges, and we've done that. So step number two is to recombine the ions to form the products. So we are going to take the cation and put it first, and we're going to take the anion and we're going to put it second. All right, so we are going to take magnesium cation and we're going to recombine it. It was with sulfide, but now we're going to recombine it with hydroxide. And we're going to write that as a product. And the correct formula for Mg2 plus with OH -1 is Mg. How many OHs do we need?
Two.
Yeah, we need 2 of them. Okay, so that's going to be our first product. Our second product, we're going to take our cation and our anion, and we are going to put them together. Now, I want you to watch out. Don't just start flinging them together like this. Don't be like SR, because that's the order that they're in. No, you always have to put the cation first, and that is the strontium because it's 2 plus. Strontium is 2 plus, S is 2 minus, so our correct formula for that is SRS. Okay, so second, we recombine our ions. And we make sure the cation is always first. And we make sure that the charges work out. Okay, the charges have to balance. You can't just throw any random number of ions into that. Okay, the next thing we're going to do is to balance the reaction. You guys have gotten pretty good at this now. So let's take a look and let's see about balancing the reaction. So 3 is balance the reaction. So we have, actually, that's already balanced because we've got 1 of everything except for the hydroxide. The hydroxide we have 2, so we are actually done that. No coefficients this time. We are now going to write in our aqueous and solid. How do we know who is aqueous and solid? We're going to use the solubility table. If it says low solubility, that means it's going to be a precipitate. But if it says soluble, that means it's going to be aqueous. So let's look at our substances. First of all, you can pretty much assume that I will have given you aqueous compounds for the reactants. You can confirm it by looking it up, but if you have a solid block of MgS, okay, and a solid block of SrOH2, they aren't going to react because the ions are not going to be able to interact with one another in the solid form. They're bound up in that crystal lattice structure, so they have to be dissolved. So you have to assume that your reactants are going to be aqueous before you start. However, you could look them up if you wanted to and say, yes, oh, Ms. Spence didn't make a mistake. She gave me aqueous compounds. So we are going to look up MgOH. And remember, when you look up things, this is step 4, look up the solubilities and put in solids and aqueuses. So if we go to our solubility table here, I think this is it. No, it says solubility table, but there is no solubility table. Let me find it. That one. Oh, excellent. Okay, the compound we came to look up was magnesium hydroxide. Okay. We came to look up MgOH2. Usually we start by looking up the anion, which in this case is OH minus, and so that will be in our left-hand column. Okay, here we go. In the most left-hand column, you'll see the negative ions. And in this case, we are looking for hydroxide, so we're just going to go down until we get to hydroxide. Oh, there it is there. We found it, and remember we were putting it together with magnesium, and we were going to decide if that was soluble or not. So hydroxide, we don't have hydrogen or ammonium or strontium. Is magnesium an alkali ion? Is magnesium an alkali ion?
Yeah.
Niet.
No.
No, it is not. The alkali ions are lithium, sodium, potassium, rubidium, cesium, and francium. And I know I keep telling you to write them in, but don't hesitate, write them in there, okay, so you don't forget. So magnesium is not one of the top rows, so it falls in the all others category. And if it is in the all others category, it is low solubility. What state will it be if it is low solubility?
Solid.
It'll be a solid, yeah. So let's go back. So we have MgOH, and that is a solid. We can look up strontium sulfide. Okay, so we're going to bop back to our solubility table. And we're going to look up strontium sulfide. Remember, you're going to go look up the anion. The anions are in the left-hand column. Here is sulfide, and we're looking up strontium sulfide. And strontium is soluble with sulfide. So that means it will be what state? If it is soluble, it will be
Aqueous.
aqueous. That is correct. Okay, so that is step number 4. Look up the solubilities and write in the states. So we have done step number 4. Okay, let's go back to, okay, so we have written the formula equation. All right, formula equation is done. Okay. And now, so if you've just joined us, we are looking on this, this is a resource document that just tells you, it's a one-pager that tells you how to write formula equations, complete ionic equations, net ionic equations, and find the spectator ion. And this document is in our files section. Okay, so we have finished writing the formula equation. Next step is to write the complete ionic equation. And this is going to use part of what we were doing last week. We are going to separate the ions for the ionic compounds, which are aqueous. You need to use both the coefficients and the subscripts to find the total number of each ion, and we will leave the solids together. So in essence, what we are doing for step 5 is to separate aqueous, but not solid. Okay, that's a shortened version. So make this a bit smaller so we can see it on our screen while we write the next step. There we go. Okay, so we have MgS. Oh, just one of each. That's easy. So we have Mg plus S. Next, we have strontium hydroxide. We have 1 strontium, and then we have OH2. I'm waiting for someone to yell at me or be like, Miss Vance, what are you doing?
About what? About what?
About what I've written.
You
Let's
put
take
the
a
charges,
look.
your charges and your aqueuses.
Yeah, my charges are missing all over the place. My aqueuses
sure
are
you do
missing.
that.
Okay,
Yep.
so yeah, so I need to put in my charges and I need to put in my aqueuses. All right, there we go. Aqueous 2 plus aqueous. Honestly, if you want to go through at the end and just put in all your charges and your aqueuses, you can do it look a little bit like a production line. Does anyone take issue with how I've written my hydroxide? Anyone have a problem with how I've written the hydroxide?
The 2 should be in front of it like a coefficient.
That's correct, yeah. The hydroxides are not attached to each other. So if I have my beaker of water, I don't have an OH attached to another OH, okay? I don't have OH2. I have 2 OHs, and they're floating around separately from one another, okay? And the charge is missing, yeah, okay? So I need to fix that. I don't want to write it as OH2. I want to write it as 2 OH minus and aqueous. Now, next I have a solid, and solids stay together. So that one's really straightforward, just MgOH2. That's a solid. And then shove this over a little bit so I've got room to finish. Our last compound is strontium sulfide aqueous plus, and it is aqueous, so we split it apart, Sr aqueous plus S aqueous, and I shouldn't forget my charges. There we go. Okay, so that, once you have split that up, you have done steps 4 and 5, and that's it for the complete ionic equation. It's just 5 and 6, I guess. 5 and separate the ions, leave the solids together. I could have put that as 1 step. I'm not quite sure why I made it 2 steps. But anyway, separate the aqueous, leave the solids together. That's your complete ionic equation. Complete ionic equation. Now, to get to your net ionic equation, there's 2 ways to look at it. Once you've gotten this far, you can look and say, in my net ionic equation, I can look and say, my net ionic equation is going to produce my solid. Okay, so if we go back here, one way of doing it is to say, write the precipitate as the only product. Okay, that's one possibility. So let's try it that way. If my
Isn't most of the time the precipitate is like only just only one?
There is sometimes 1, there are sometimes 2, less often there are 2, and sometimes there are none, in which case there's no reaction, but most often you're going to have 1 precipitate, but you could have 2, okay? Yeah.
So, it is possible to have two, but most of the
totally
time it's only
possible.
one.
Yeah, yeah.
Got it.
Okay.
Thank you.
Yeah. And so if you write this as your product, all you have to do is say, who makes that product? Well, that's going to be your hydroxide and your magnesium. So you would write Mg 2 plus aqueous plus 2 OH minus aqueous goes to MgOH. Oops, I forgot my 2 solid. And that would be your net ionic equation. So that is one way to do it. Okay. Second way to do it would be, get rid of this. Oh, didn't want to do that. Second way to do it would be to first identify the spectator ions. Oh, and by the way, if you do it this way, where you just say, okay, I'm going to do the net ionic equation, I'm going to put the solid on the right, and I'm going to put the ions that make it on the left, you can identify your spectator ions because they are the ones that are not in this equation. Okay, so that would make your spectator ions the strontium, the sulfide, the strontium, the sulfide. The other way to do it is just backwards from that. You identify your spectator ions first, and you do that by saying, who doesn't change? Identify the spectator ions. Who doesn't change? Well, sulfide starts as S2 minus and sulfide finishes as S2 minus. It's identical from side to side. Strontium starts as S2 plus, or SR2 plus. It finishes as SR2 plus. It is identical. On the other hand, Mg2 plus is no longer Mg2 plus. Now it's part of a solid. So it has changed. So that is not a spectator ion. Spectator ions are the ones that don't change. So when you are asked to write the spectator ions, you would simply write Sr2 plus and S2 minus. Okay. Question F is, we have NH4, 2 SO3 plus Al2 SO4 3. Excuse me, I'm just choking on my own spit. No COVID, just choking on my own spit. Excellent. Love it. So we need to predict our products. What is the first step we do in order to predict our products?
Write out the charges.
Yeah, write out the ions and their charges.
Remember to do, always remember to do that.
Yeah. So you are going to write out NH4, which has a positive 1 charge. You are going to write out SO3, which has a 2 minus charge. You will write out aluminum, which has Al3 plus. And sulfate, which is SO4, 2 minus. So step 2, now that we've written out the ions and their charges, what are we going to do?
Wait, Miss Spence?
Yeah.
Why does SO3 and SO4 have the same charge?
That they just do. If you look them up on the polyatomic ion chart, they just do.
Oh, okay, never mind.
Yeah, there's no deep meaning behind it. Ours not to reason why. Yep. So what do we do once we know those ions and their charges? What do we do next? We know the ions, we know their charges. We're trying to get eventually to the complete ionic, net ionic, blah, blah, blah.
Put the anions and the cations together.
Mm-hmm. We recombine the ions. Okay, so we are going to take aluminum and put it with ammonium, right? Am I correct? Am I going to put aluminum with ammonium?
No.
No, because they are both.
Anions.
They're both, yeah, they're both cations. So I need to put my cation with my anion. This is +1. NH4 is +1. SO4 is -2. So we would need to have NH4, 2 SO4. And then aluminum is going to get together with sulfite. And I've got 2 aluminums here, so it's going to be Al2 and then SO3. Right?
Right.
So if I take my aluminum, which is 3+, and I put it together with SO3, which is 2-, do I get Al2SO3?
No.
No, so you have to be careful. You can't just take the numbers from here and say, oh, that's the same numbers I'm going to have over here. You can't do that. That's why you write out the ions and their charges. So you can say, I have Al3+, I have SO4 2-. That means I'm going to need 3 of the SO3s and 2 of the aluminums. Yeah? So I will need 2 aluminums and I will need 3 SO3s. That's going to give me a 6+ charge here and a 6- charge. That gives me a neutral compound. Okay, so always make sure you've written the correct formula, not what you think it would just be just because it was easy. Okay? Okay, after we've done that, where do we go look? Or what do we do first? Actually, before we go look there, we do something else.
Right. Balance the equation first.
Yeah,
please.
we balance it. Okay, so let's do that. We have, let's see, I'm going to do something. You know what? Somebody gave me a tip. I was listening to one of the videos that I recommended to you guys on ionic equations, and he said, balance the things that you have the most of first. And I'm like, oh, that sounds good. And in fact, it does. It works out quite nicely. So I have a lot of SO4s. I've got 3 of them. So what if I put a 3 here? Okay. Well, that now means that I have 6 NH4s. Well, over here I have 2 NH4s, so I would need to put a 3, right? Because that would then give me 6 NH4s. And that gives me 3. Remember that this 3 also applies to the sulfite. So I have, oh my gosh, I have 3 sulfite, and I have 2 aluminum, and I have 2 aluminum, and hey, I'm good. Excellent. So step number 3 is to balance. And to finish this up, what's step number 4?
Aqueouses.
Aqueouses. Okay. Do you guys feel confident looking them up, or do you want another practice with that? Ammonium is, okay, ammonium is soluble with everything. So that's going to be aqueous. Aluminum sulfate, I told you that I'm always going to give you soluble reactants. So it's going to be aqueous, even though I might have to look that one up. Ammonium is soluble with everything. So this will be aqueous. And I happen to know that sulfite is soluble with very, very few things other than our alkali ions and ammonium and hydrogen. And so it is going to be, oopsie, it's going to be a solid. Okay, so we've got that. That is our, what kind of equation do we call this that we have right here, this whole thing? What kind of
Formula equation?
That is our formula equation, yes. Okay. And now from there, we're going to do our complete ionic equation. What do we do for our complete ionic equation? What do we have to do?
Separate them all.
Mhm.
Except for the solid.
Separate them all except the solid. Yep. Okay, so what I'm going to do is I'm actually just going to write down the ions, and then you guys are going to figure out the coefficients, okay? So I've got NH4 plus, I have SO3, 2 minus, I have Al, 3 plus, and I have SO4, 2 minus. Those are my reactants, and then my products I'll actually write on the next line because otherwise I run out of room a little bit. I have NH4 plus, I have SO4, 2 minus, and then I have my solid, so that's going to stay together. So I have Al2, SO3, 3. So I'm going to write in all my aqueouses. Make sure I haven't forgotten any charges. Oh, look, I've written all my charges. That's good. Aqueous, aqueous, solid. Okay. Now I want you to think about this. What should our coefficient be for this ammonium here? What should our coefficient be for the ammonium? Yeah, absolutely. We have 3 here, and we have 2 down here, which means in total we have 6.
6.
Yeah. Okay, what is the coefficient for the sulfite? It is, yeah, I'm getting a whole bunch of 3s in the chat. Excellent.
Also 3 as well.
Yeah.
Yeah, 3.
Okay, because we have 3 of them. Remember that this 3 is part of sulfite, so it's not like all of a sudden I have 9 sulfites, because that 3 is part of 1 sulfite. Okay. How many aluminums do we have? 2, that's correct. And then how many sulfates? SO4. Yep, 3 of them. Okay, because that's from our subscript right up there. Okay, and moving on into our products. We have NH4, and if you have 6 on this side and you don't have 6 on this side, there will be a problem. It means it's not balanced. Fortunately, guess what? Oh, we do have 6 of them. Excellent. How many SO4s?
3, same thing.
3, same thing, which is good because how many did we have on this side? We had 3, so it's a good thing that those 2 are the same. If they aren't the same, you've done something wrong because it has to be balanced on both sides. You can't have sulfates appearing out of nowhere and disappearing and all kinds of things like that, okay? And then finally, oh, there was no coefficient for this and it's not an ion anyway. So that was our complete ionic equation, also known as the total ionic equation. Okay, just tidy it up a bit so it doesn't look as messy. Can you look at that and see what the net ionic equation would be? Who would our reactants be? That's our CIA. Who would our reactants be in the net ionic equation? is NH4, is it a reactant or is it a spectator? Is NH4 a reactant or a spectator?
Spectator.
It is a spectator. Mm-hmm. So that means that on both sides, we have NH4, which means that when we go to our net ionic equation, we can cancel those out. Is SO3, is it a reactant or is it a spectator? SO3.
Reactant.
Yep, it's a reactant because it is on its own and now it is part of a solid. So there has been a change of what chemical it is, and so it is a reactant. So we're going to write that as one of our reactants, SO3, 2 minus. How many do we have? We have 3 of them. Okay. Our aluminum is also changing. It's becoming part of the solid, so we're going to have 2 aluminums. And is SO4 a reactant or is it a spectator?
Alone. It's probably alone. SO4.
Alone?
Yeah, like
What do you mean?
yeah, what I mean is like spectator.
A spectator.
Like,
yeah, it is a
it's not-
spectator.
that's what I mean by alone.
Yeah, I getcha. So here it is on one side, here it is on the other side. It looks identical on both sides. That means it is a spectator ion. And so we will not include it in our reaction. It will get canceled out. And so our product then will be, we have Al2SO3, 3 solid. And look how good that is. We have 3 sulfites. And over on this side, we have 3 sulfites. On this side, we have 2 aluminums. And over here, we have 2 aluminums. And if we were asked to identify, see there, we'll get rid of that, our spectator ions, you can say, okay, well, we did that. We crossed them out up above. So we had our NH4s and we had our SO4s.
Do we have to put the coefficients in front of the spectator ions?
No, and in fact, I don't want you to. I was going to ask you what was wrong with this.
Oh, okay.
Okay, we do not we do not put the coefficients in front of when we're identifying the spectators, because that would imply that only 6 of all the millions of ammonia present, only 6 of them were spectator ions, right? And you know that it's not just 6 of them. If you have a beaker full of these things, there's going to be billions and billions of ammoniums. So do not include the spectators, or sorry, coefficients rather, when identifying spectator ions. Identifying spectator ions. Okay, so no. Is there anything else wrong with what I've done with those spectators?
Charges, please.
Yep. Okay. Here I would think you kind of have a choice as to whether put the solid or the aqueous. Oh, by the way, back up in my net ionic equation, I forgot to write the aqueous here. Oopsie. Sorry about that. Okay,